What components are best for electrical engineering signal amplification? If you are curious about the best components for signal amplification in electrical engineering, you are in the right place. Signal amplification is essential in analog signal processing and control systems. The aim is to boost the amplitude of a signal while keeping its original characteristics intact. When selecting components for signal amplification, consider several factors. These include the type of signal, frequency range, required gain, linearity, noise performance, power consumption, and the specific application. Let's start with transistors. Bipolar junction transistors are commonly used for voltage and current amplification in low to medium frequency ranges. They provide high gain and quick response, but they need careful biasing. On the other hand, field effect transistors, which include junction field effect transistors and metal oxide semiconductor field effect transistors, have high input impedance. This makes them ideal for amplifying weak signals without affecting the source. You will often find bipolar junction transistors in audio amplifiers and switching circuits, while field effect transistors are preferred for low-noise amplifiers and high-frequency applications. Next up are operational amplifiers. These integrated circuits are designed for voltage amplification and offer high gain, high input impedance, and low output impedance. They allow for flexibility through external feedback components that help set gain, bandwidth, and frequency response. Operational amplifiers are widely used in analog signal processing for tasks like filtering, buffering, and amplification. You can find them in instrumentation amplifiers, audio preamplifiers, and sensor signal conditioning. Vacuum tubes, though less common today, were historically used for high power and high frequency amplification. They still appear in specialized audio equipment due to their unique sound characteristics. Transformers are another important component. These passive devices can provide voltage gain through electromagnetic induction. They are useful for impedance matching and isolation in audio and radio frequency circuits. You will see transformers in audio amplifiers and radio frequency signal chains. Lastly, don't forget about discrete components and passive elements such as resistors, capacitors, and inductors. These components work alongside active devices to shape frequency response, stabilize gain, and filter noise. They are essential for biasing networks and feedback loops to ensure proper amplifier operation. When choosing components, consider the frequency range. High-frequency signals may require specialized transistors or wideband operational amplifiers. Noise performance is also key. Low-noise transistors and precision operational amplifiers are ideal for sensitive applications like sensor amplification. Power handling is another factor. Power transistors and robust operational amplifiers are necessary for driving loads or high-power signals. For audio and precision applications, components with low distortion characteristics are preferred. In practical applications, you will see signal amplification in various areas. For instance, sensor signal conditioning often uses low-noise operational amplifiers or field effect transistor input stages to amplify weak sensor outputs. Audio amplifiers may utilize bipolar junction transistors or integrated power amplifiers to drive speakers. Radio frequency amplification employs specialized transistors and impedance matching transformers to ensure signal clarity. In feedback control systems, amplifiers with precise gain and stability are essential for maintaining system performance. The choice of components for signal amplification ultimately depends on the specific requirements of each application, balancing gain, noise, frequency response, and power considerations. Transistors and operational amplifiers remains the most versatile and widely used components in this field.